Welcome to the session on straight line graphs, modelling with straight lines. The objective for this session is to use straight line graphs to construct mathematical models. When two quantities increase at the same rate, they are in direct proportion. The graph of these quantities is a straight line through 0, 0. In other words, for example, when x increases by 1 unit, y increases by k units, or y is equal to k times x. Have a look at this example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's consider the solution to example 1a first. We are required to consider the graph shown on our screen and calculate the gradient k of the line. Notice that when x increases by 0.5, y increases by k. Now k is the gradient of the line, so change in y over change in x. The change in the y coordinates is 4 minus 2, and the corresponding change in x is 1 minus 0.5. So therefore k is equal to 4. Now let's solve example 1b. We are required to write an equation linking y and x. We know that y is equal to k times x, but we know that k is equal to 4 from part 1a. Therefore, y is equal to 4 times x, as shown. It is possible to use a linear model to show the relationship between variables x and y. Variables are related by an equation of the form y equals mx plus c. If points in a dataset lie close to the line, then a linear model can still be fitted to the data. A mathematical model is an attempt to represent a dataset using an equation. So let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2a first. The cost of producing a website is a flat rate and then an additional rate per day as shown. Is a linear model appropriate for this data? First, let's produce a graph of the data to establish this. Here's a graph. The number of days goes on the x-axis and the price goes on the y-axis. It seems that we can fit a line to this data, as you can see, as the data is following a straight line, so a linear model is appropriate. Now let's take a look at part B. We are required to deduce an equation of the form P equals m times d plus c, where P is the price and d is the number of days. So let's find m, the gradient. So considering any 2 points, we have that the change in y is 210 minus 190, and the corresponding change in x is 6 minus 4, to give that m is equal to 10. Now let's find c. When d is equal to 0, p is equal to 150. So let's plug this into our equation. So substituting in the equation p equals m times d plus c gives us 150 for p is equal to 10 for m times 0 for d plus C. And so tidying up gives us that C is equal to 150. So the equation is P equals 10 times X plus 150. Now for example 2C. Interpret the meaning of M and C. So here's our equation, P equals 10x plus 150. This means that when x increases by 1, the value P increases by 10. For C equals 150, we have that when x is 0, P is equal to 150. This means that the flat rate of producing a website is £150. Now for example 2D. Use the model to estimate the price when the number of days is 15. Now P is equal to 10x plus 150. Therefore, if we substitute x equals 15 in the equation, here, we obtain P is equal to 10 times 15 plus 150. Which equals 150 plus 150, which is of course equal to 300. This brings us to the end of this session. If you have understood its contents, you should be able to use straight line graphs to construct mathematical models. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.